And with that, okay, so with a lot of introduction and fanfare, I'd like to introduce you to Chris Parker, who's been working with the Salty Dogs for a number of years and advising us on whether for all our rallies and for many of us personally when we're doing offshore passages. And with that, I'm going to turn it over to Chris.
Thanks, Alex, and good afternoon, everyone. So we'll talk about a couple of topics this afternoon. One is kind of overall weather patterns, and then where we're going to be within those weather patterns. A little bit on timing and the challenges of various timings for moving south to the Caribbean. We could get into a little bit of weather in the Caribbean if anyone wants, and I'll mention briefly at the end what sort of forecasts you can expect from us and what else you might want along the way. So just to get started, this is a WeatherFacts chart, and it's kind of ugly, but the really only important thing we need to get from it for our discussion is that the large scale wind is driven by a difference in pressure over distance. It's driven by the pressure gradient. So it's important to understand where the high pressure systems and low pressure systems are and how strong they are, where the fronts are, because a frontal boundary or any sort of a trough, a frontal boundary is a sort of a trough, actually has a pressure drop across it. So it is actually an area of relatively lower pressure, and all the associated weather that goes along with areas of relatively lower pressure apply for troughs and fronts. So on this chart, there's a lot of information here, and some of you may look at that and understand every little piece of information on it. But I imagine that for most of you, it looks a little bit like a chicken got black ink on its feet and walk across the page. But again, really the only information that we need to derive from this is that there is a relationship between the pressure gradient and the wind. So these are wind flags, and notice this wind flag is, that's 35 knots. There's 1 full feather, 2 full feathers, 3 full feathers, and a half a feather. This is 40 knots. There's 1, 2, 3, 4 full feathers. That's 40 knots of wind. And that's blowing from the south. The wind always blows toward the base of the stalk. So that's a south wind at 40, a south wind at 35. This would be a south-southwest wind at 35. Up here, we have a west-southwest wind at 35. That's a west-southwest wind at 50, the filled-in triangle. Now, I don't know about you, but I'm a fair weather sailor. I like broad reaching and 15 or 20 knots of wind. You know, I can deal with more than that. I've been out in more than that, but ideally, I would like to be broad reaching in 15 or 20 knots of wind and, 4 or 6 foot seas and quite pleasant sailing conditions. What I don't see on this chart is any wind that's in the 15 or 20 knots range. So looking at that chart, just on the surface, it doesn't really tell me where I would want to be. It certainly tells me where I would not want to be, anywhere where there's a wind flag, because they're all 35 knots or higher. So what else do we notice about where we have wind flags? There are these squiggly lines that are close together where we have wind flags, and these are pressure lines, lines of equal pressure. They're called isobars, iso meaning same and bar meaning pressure. So the pressure is the same anywhere along that line, anywhere around the Earth. This line that has a 0.8 in the middle of it is 1,008 millibars, 1008 millibars. Now, how do we know that? Well, it's an isobar, it's a pressure line of equal pressure. And in order to reduce the visual clutter on the chart, any extraneous information that can be removed is removed, as long as it doesn't introduce ambiguity. Now, Could that be any other number other than 1,008 millibars? Could it be 1,108 millibars, 1108? Well, no, it couldn't, because that pressure doesn't exist on Earth as we know it. Could it be 908 millibars? Well, if we were in the middle of one of the strongest Category 5 hurricanes on record, it could be 908 millibars. But let's assume that it's not 908. We're not in the middle of one of the strongest Category 5 hurricanes ever. Through the process of elimination, we know that has to be 1008 millibars for the pressure. So if we follow this line anywhere along the chart, it's 1008. It kind of goes off the chart there and comes back on the chart there, 1008. We follow it around this area of low pressure, 1008, up here and across this front, and it's still 1008 millibars, and then it goes off the chart there. The next line has a 16 in the middle of it. So if we follow that line, it's 1016 millibars over northern Ontario. And then it's still 1016 millibars right there. And it's still 1016 millibars over Ireland. And then 1016 millibars where it goes off the chart right there. So these isobars are typically spaced every 4 millibars on a WeatherFax chart from the US. And so we've got 1008, 1016. So that's going to be that line in the middle, what, 1012. So notice that where all the wind flags are, we've got these isobars packed really, really tight. And where there are no wind flags, the isobars are spaced much more widely apart. So there is going to be more wind where the pressure isobars are packed more tightly, and there's going to be less wind the looser they are packed. And right underneath the area of high pressure, there's no wind at all. So if you want to paint a picture of what the wind is like in the Northeast Atlantic, there's no wind at all from France toward the waters north of the Azores. And as we move north away from the ridge of high pressure, we'll pick up a gradually increasing west-southwest wind. And as we get up into this area, it's increased to around 35 knots. And as we keep going north toward the area of low pressure, there's one area that's up to 50, but mostly we're in the 40, 45 knot range up here close to a low pressure system, which is just off the chart over or north of Iceland. So pressure gradient and wind have a direct relationship, and the stronger the area of low pressure, the closer the area of low pressure to the area of high pressure, the tighter the wind gradient, the stronger the wind. You can think of it this way as well. I kind of like this analogy. Car parked on the top of a hill, parking brake is on, car is not moving. This is how it would look on a cross section of a mountain over land, and this is how it would look on a WeatherFax chart. We take the parking brake off, and what is the car going to do? The car is going to start to move. Now, I know it looks like it may start moving to the right. Trust me, it's going to move to the left. But how is the car going to start moving as it's just beginning to accelerate from a dead stop? It's going to start moving slowly at first. And as the slope of the line increases, the car is going to get rolling faster and faster. And as long as the slope of the line remains fairly steep, the car is going to keep picking up speed, even with a constant slope of the hill. Over time, the car is going to keep picking up speed as long as the slope of the hill is steep. And then as the slope of the hill becomes more gradual, the car is going to slow down and roll to a stop at the bottom of the hill. And the same thing actually happens with areas of high and low pressure in the atmosphere. Typically, areas of non-tropical low pressure systems, there's an area of light wind near the center of that low. And it's a somewhat tricky proposition, but we have successfully navigated a lot of folks through the middle of areas of low pressure where there were gales going on all around them, and they were in the middle of the low and were able to move for several days along with the low, as long as the low was moving at a speed that was similar to their speed. And then, the low decays and they emerge from the low, and conditions aren't bad when they emerge from the low. So that is a somewhat tricky forecast because the low has to be moving at a speed similar to the boat, because otherwise the low will overtake you and you'll get in the strong wind around the periphery of the low before the low decays. But it can be done. So getting in the middle of an area of low pressure is not necessarily a bad thing because the winds are typically fairly light, but it is risky and only works in a very limited number of situations. Generally, we want to stay away from areas of low pressure and away from strong cold fronts because typically we're in this area on the hill where we've got a lot of wind going on as a low pressure system or a cold front approaches and passes. So that's kind of just a bit of an overview of how wind behaves with high and low pressure systems and the relationship between wind and the pressure gradient. For moving from the US to the Caribbean or back in the spring, I really think it's instructive to think of the atmosphere and the trip in three parts. If you are moving from the US coast to the Caribbean or vice versa, just about any time of year, you are going to be in three different types of weather systems. You won't really be in the polar area underneath the polar high, but you will be in the mid-latitudes where we've got low pressure systems and cold fronts passing with a fair regularity. You will be in the subtropics where the wind tends to be fairly light around an area of high pressure or a ridge of high pressure. And you will be down in the tropics where you've got an easterly trade wind flow on the south side of that subtropical high pressure ridge. So let's look a little bit about the weather in these zones. Just on a global scale, the air moves through these three zones, not in a perfect north-south direction because of the Coriolis force, because of the rotation of the earth. Wind moves in a somewhat circular fashion in cells through each of these zones. Let's start in the tropics. And in the tropics, we have what? We have warm air, we have moist air, and we have an area of relatively lower pressure along and just north of the equator that is semi-permanent. So what do you think the characteristics would be of relatively low pressure, warm air, and warm moist air? Well, would it tend to rise or sink? It would tend to rise. Warm air rises, and air in relatively lower pressure also rises. There are fewer air molecules packed above the surface, so the pressure is lower. And with fewer air molecules in the column of air, air is able to be buoyant and generally rise near areas of low pressure. So these green arrows indicate air rising from the surface over in near the equator. And then when those green rising winds get up into the upper levels of the atmosphere, some of them turn south toward the South Pole, and some of them go north. We're going to focus on the air molecules that go north along that black arrow. So these air molecules are moving north, trying to redistribute energy, all that heat and all that moisture from the equator to the North Pole. And when they get up to the subtropics around 25, 30, 35 degrees north, they hit air that's flowing to the south. And this creates a big pileup of air molecules in the atmosphere. And that big pileup of air molecules in the atmosphere makes the air heavy. So it sinks. And we've got these purple areas of air that's sinking over this area of relatively higher pressure in the subtropics. Now, some of that air is going to return toward the equator, and some of it is going to go toward the North Pole. So we get up into the upper latitudes, 35, 40, 45, 50 degrees north latitude, and we get areas of low pressure and cold fronts that come along. And in the areas of low pressure, again, we have generally rising air. So that's illustrated by the green arrows. Some of that goes back toward the equator and some goes toward the North Pole. And then over the pole or near the poles, we've got relatively heavy sinking air again, and that's the polar high. Now, you've heard of the polar vortex in the winter that brings bitterly cold temperatures. Well, that's an area of relatively high pressure that is over or near the poles, and the air is flowing outward at the surface from that down toward the equator, and that's what brings the the super cold air that's 10, 20, 30, 40 degrees below zero in New England sometimes in the dead of winter. The polar vortex, scary name. So the air that's leaving the equator, this is kind of interesting, is warm and moist, and it's got a very high state of energy. And as that air is gradually moving through the atmosphere up and down, it's losing energy all the way to the North Pole. And by the time the air gets up here, it is very cold and very dry and has a very low energy state. And much of that energy is dissipated in this upper latitude low that you're going to find around 35, 40, 45, 50 degrees north latitude in the fall. So we want to avoid the area where that is, where all that tropical energy is being dissipated in the atmosphere, because the effects are pretty violent sometimes. So let's focus a little bit more on this band up here, the upper latitude low. Air in this zone is characterized by moist rising air. There is surface convergence, air moving up from the south and down from the north. And it's a zone through which migratory low pressure systems pass. These mark the boundary of cool air to the north and warm and moist air to the south. Frequently, there's strong precipitation and strong winds. Discrete areas of low pressure systems form along that track. And when the warm and cold air masses collide along a strong cold front, we get some really nasty weather. Typically, this front will press south, and then ahead of the next area of low pressure, it will lift north again as a warm front. And this is a pretty persistent thing. It's something we call the polar front. So the track of the areas of low pressure is called the storm track. And they tend to follow one another at a similar latitude. Sometimes one low will be further north than the previous or further south than the previous, but areas of low pressure and cold fronts tend to train along a similar area, one following another. And the storm track is the track of low pressure systems. The polar front is the persistent trough that divides the warm air and the cool air. And the storm track is generally along that polar front. And again, that's going to press south in the wake of a low. After a low passes, the cold front pushes south. And then ahead of the next low, it lifts north as a warm front. You've seen this along the US East Coast this summer. So remember the days and maybe a week or two where you got nonstop 100-degree heat, really humid, really muggy, really uncomfortable. And then you got a fairly strong cold front come through, and the days behind that front were characterized by much cooler air and much more variable conditions. What happened there is the polar front had lifted north of you, and then a low pressure system passed and the cold front came south again. The polar front moved south, and you're in the cooler, drier air on the north side of it. The other thing that's important is the prevailing winds on the south side of that polar front are typically southwesterlies. And the air on the north side of that polar front, where it's cooler and drier, those winds can be quite variable in wind strength and direction. So this creates some challenges for folks moving south along the coast, because let's say if you're moving from New England to the mid-Atlantic states, your direction of travel is really southwest. So that means that if you are moving at a period of time when you are south of the polar front, where it's warm and moist and humid, you're invariably going to have southwest winds, which are right on the nose. And then a cold front comes through, you get a little break from the southwest winds, and then the wind can be anything. It can be variable at all sorts of speeds and directions. But then ahead of the next low pressure system, you rebuild the southwest winds again. So we'll get into a little more detailed discussion about that in a moment. So where is the polar front? Well, the polar front is right along those areas of low pressure, and it kind of zigzags north and south as each low pressure system passes. The low passes and the polar front dips south. Ahead of the next low, it lifts north as a warm front. The low passes and it goes south again. Ahead of the next low, it lifts north as a warm front, et cetera, et cetera. So that's the big dividing line in the atmosphere. And that's what we're going to face the first few days of the trip, typically leaving from New England or the mid-Atlantic states in early November. So what happens when we get down south of where all those cold fronts and low pressure systems are? Well, we get into this ridge of high pressure. And again, that is heavy sinking air. And this can be a persistent area of high pressure. It's typically along about 30 degrees north latitude, although it varies. It presses further south in the winter and it lifts a little further north in the summer. It's characterized by very settled weather and typically light wind. And along the south periphery, we have increasing wind that is, it can be east-northeast or east or somewhat southeast. And that would be as we are just getting into the, yeah. So I'm sorry, if we get a cold front passing and we're just getting into the ridge, then the wind is going to start veering from the west behind the front to the north, then the northeast, then the east, then the southeast. We move through the ridge, and then the wind is out of the southwest on the south side of the ridge. If you're down in the Caribbean, then you're typically going to get east-northeast winds in the Caribbean, because you're well south of the area of high pressure. Yeah. So what do we have when we get down into the Caribbean? Well, typically on approach to the Caribbean, we're going to have moderate trade winds out of a direction that is either somewhat north of east or somewhat south of east. And we start to get more squalls, particularly at night. So anywhere south of the ridge, anywhere where we've got the easterly trade winds in place, we can expect to see nocturnal, nighttime squalls almost every night. Now, some nights there are more, some nights there are fewer of those, and some nights they're stronger, some nights they're not as strong. But typically we're going to start seeing nocturnal squalls as we get into the more warm, moist, humid air of the tropics. just want to talk about a couple of other things before we get into strategies for leaving from each point along the US East Coast and what some of the challenges are. So this is kind of a cool chart. It's from the European Met Office, and it is the global average annual wind. And it's the annual mean wind. This is the wind scale, so anything below 2 meters per second, which would be about 4 knots on an average annual mean level. Anything below 2 meters per second or about 4 knots would be in white. Anything between 2 meters per second and 4 meters per second or about 4 to 8 knots is in yellow. And anything above that is in green, then blue, then purple. And the first thing I noticed from looking at that is that in the Northern Hemisphere, we've got very few of the deep blue areas. In the Southern Hemisphere, we've got a lot more deep blue areas. And that's because in the Southern Hemisphere, there's much less landmass, there's much more ocean, and there's less friction over ocean. So the wind gets blowing faster. And the reason that we don't have, again, as many of the really strong winds in the Northern Hemisphere is there's a lot more landmass, and that adds friction and keeps the global annual mean wind down. The other thing I notice is that just looking at the Atlantic between here's the US and here's Europe and Africa, there's this zone of very light wind around, this is 30 degrees north latitude, there's Jacksonville, and this is 35 north, there's Cape Hatteras. So between about 30 and 35 north in the West Atlantic and maybe between 35 and 40 north in the Eastern Atlantic, we've got this zone of really, really light wind. Well, why is that? That's the area of subtropical high pressure. So on the south side of that, notice that the wind is north along Portugal and Spain and northeast along Northern Africa, the Canaries down to the Cape Verde Islands. And then it takes on a more easterly direction as it blows across the Atlantic toward the Caribbean. It's mostly an easterly wind in the Caribbean, and it's fairly brisk. So the reason that those winds are strong is we're south of that subtropical high pressure ridge that's got the light wind. We've got more of a pressure gradient, and we typically have easterly trade winds in the Caribbean. If you want to sail to Europe, the best way to do that is to get north of the subtropical high pressure ridge and use the southwesterlies and westerlies to be at your back, sailing a nice broad reach or downwind to Europe. You can do it from the Caribbean. From the Caribbean, you'll have to go north out of the trade winds and across the ridge, and then pick up the southwesterlies and carry them to Europe. If you're leaving from the US coast, you can jump right into the southwest and west winds and ride them to Europe. Now, again, the latitude of this ridge changes a little bit during the seasons. It's a little further south in the winter. It's a little further north in the summer. But that's kind of cool. It gives you an idea of, a visual representation of why the sailing ships chose the trade wind routes and why those routes make sense based on what we now know about where the zones of high and low pressure are and the characteristics of those 3 zones that we're going to be traveling in. And this one is maybe not quite as important, but I thought it was kind of interesting. There's moisture plays a big part in our weather. Where we have a lot of moisture, we have condensation, and that releases a lot of heat into the atmosphere and helps to make violent thunderstorms and really nasty weather. And so this is a moisture, and for us, the important thing is a latent heat energy. That's the potential energy that is in water vapor, and it's released into the atmosphere when we get condensation. This is the global cycle of moisture and net evaporation. So this chart shows us evaporation minus precipitation, and it's the average annual mean around the world. So what does that mean? This is the scale. And if the number is negative, that means that we've got more evaporation than we have. I'm sorry, if the number is negative, we've got more precipitation than we have evaporation. So areas that are negative have quite a bit of precipitation, but not very much evaporation. Areas that are positive have a lot of evaporation minus a relatively smaller amount of precipitation. So the area that we will be transiting from off the US East Coast down to the Caribbean is typically pretty dry. There's a lot of evaporation going on from the sea surface, but there's not a lot of precipitation on an average annual mean basis. And you would think that down in the tropics, it's really warm and there's a lot of sunshine, right? We're headed down to the tropics to enjoy the sunshine and the warm temperatures. Well, actually, there's a lot of precipitation there too, at least on an average annual mean basis. Now, more of it happens in the summer, a little less in the winter. But due to that equatorial persistent low pressure, we tend to get a lot of precipitation. Now, mostly in the winter, it'll be at night, so it may not impact your daytime plans too much. But those nocturnal squalls and occasionally a thunderstorm, that's keeping the tropical moisture green. And it's also a result of the fact that you're in this area of relatively lower pressure and that there's a lot of moisture and there is a lot of precipitation. So that's kind of interesting. When we're thinking about wind, we talked about the gradient wind thus far. And these are some characteristics of the gradient wind. It's driven by a pressure drop over distance, and that is air flowing from high pressure to low pressure, but it does so in a kind of a circular fashion. The direction of that wind is horizontal. It blows, it's not so much up and down. I mean, there is some up and down, but if you look at the air that's flowing down and out from high pressure or up and into low pressure, the slope of the air that's flowing is the air is going up or down maybe 5 miles over 1,000 miles. So it's a really, really gradual slope. It's essentially a horizontal wind, although there's a slight vertical component. This is, these winds occur on a large scale, a synoptic scale, typically 1,000 miles or so between high and low pressure systems. It's really steady wind. It's quite steady in both direction and strength. Prediction confidence, computer models do a really good job predicting the gradient winds and do a better job than any meteorologist could. And if the gradient winds were all that drove the weather, you wouldn't be in this weather seminar. I wouldn't be doing weather. We'd all be just using what the computer says, and it would be right all the time. But there are other things going on that drive the winds, and that's why we're here. The surface effects, it's a steady wind, maybe plus or minus 20% in gusts and lulls, and it's really persistent. So what else drives the winds? Well, they're convective winds, and these are driven by thermal differences within an air mass. So within an air mass, we've got pockets of wind, of air that's a lot warmer or a lot cooler. The warmer air is going to tend to rise, the cooler air is going to tend to sink. And so this is a very chaotic vertical up and down motion of air. So it's primarily vertical in direction. The scale is really small, from tens of feet to a couple of miles across. Now, the predisposition for rising or sinking air can be hundreds of miles across. But the individual cells of air that are rising or falling can be very small, from tens of feet to a few miles across. You've heard of microbursts. Well, a microburst is simply a shaft of rapidly falling air, rapidly sinking air, and it may hit you for 10 seconds or 5 minutes, but it can be really intense, and it is due to convection, up and down motion of air due to differential heating within the air mass. So convection causes wind speed and direction to vary considerably. We attempt to quantify this in our forecasts. Most forecasts don't, but we'll try to let you know what we think the potential is for wind in updrafts don't typically have a lot of wind associated with them, but particularly in the downdrafts, we're going to try to give you our best guess about what the wind potential is in those downdrafts. And we derive this from looking at a lot of different things. Some of them are precipitation based, the convective nature of the precipitation, and we use the CAPE to some extent to help with that. Forecast models are not really good with convective winds, and specifically the global forecast models are built to ignore convective winds. Convection and condensation are really, really powerful mechanisms. And if the global models that are trying to predict what's going on in areas in a grid box that's maybe 8 kilometers in size, they're trying to predict what's going to happen in every grid box 8 kilometers in size everywhere around the Earth every hour or 3 or 6 hours for the next maybe 14 days. If those models considered convection, then they would be wildly thrown off and none of the forecasts would be good. They wouldn't be usable at all. So because the convection is so strong an input that if they're wrong by just a little bit, it throws the whole forecast off. The global models typically are built to ignore most wind due to convection. So we have to make a lot of guesses about what the wind is going to be with convective events. And then there are boundary layer winds. And this sounds really complicated. Disuniformity is driven by non-atmospheric phenomena, but really it's fairly simple. There are friction differences between land and water, and that creates a difference in the atmosphere. And there are temperature differences. We have maybe cool land and warm water. Or with the Gulf Stream, we have cool water, and adjacent to that, we have warm water. Well, that creates differences in the atmosphere that don't start in the atmosphere. They start on the ground or on the water surface, and that affects the atmosphere. So these these weather phenomena depend on the nature of what's causing it. They tend to be fairly localized. The disuniformity can be from really small to maybe 100 miles across. And the influence on the weather is related to what's causing the disuniformity. Prediction confidence is often pretty good. And in some areas, there's a diurnal pattern. So along the US East Coast or some of the larger islands in the Caribbean, we get diurnal patterns where the sea breeze is blowing air toward the land during the day, and then the land breeze is blowing air away from the land at night. At night in the tropics, we tend to get more wind, and that is partly due to the fact that, so this is a little bit of a strange concept if you haven't been to the Caribbean before. In the United States, we typically think of thunderstorms occurring in the afternoon. And the mechanism there is that the sun heats the land, and the land gets really, really hot during the day. And then the warm air that's right over the surface of the land rises. And that rising air rise along with the air moving up in the atmosphere. There's a lot of moisture moving up in the atmosphere. As it moves up, it cools because the gas cools as it expands. And at some point we have condensation, making clouds, releasing heat into the atmosphere, and that can create towering thunderstorms. And then it all comes crashing down and is really messy at the surface. So that tends to occur in the afternoons and maybe into the early evenings over land. In the tropics, the timing is completely different. Those will tend to occur mostly in the overnight into morning hours. And the reason for that is that the surface of the water maintains a relatively constant temperature in the day and the night. Sure, it'll increase by maybe a half a degree or 1 or 2 degrees in the afternoon when the sun's been beating down on it all day. But that's a relatively small difference in temperature. You know, the difference in temperature over land can go from 70 degrees at 7 o'clock in the morning to the land may heat up to 120 degrees in the afternoon if you're above a parking lot at a shopping center or on a highway. So there's much more heating over land in the afternoon. Over water, the amount of heating you see is very, very slight right over the water surface. But if you look up 1,000, 2,000, 3,000 feet or more in the atmosphere, there is a similar difference in temperature day versus night. So the atmosphere above you in the tropics cools at night. So the temperature profile, if you look at a temperature profile where the temperature is decreasing with altitude, and you look at that rate of decrease, the lapse rate, we call it, in the tropics, that lapse rate supports convection only at night when the atmosphere is cool. When the atmosphere is warm during the day, the temperature is relatively constant from the surface up to a few thousand feet in the atmosphere, and there's little chance for any convection. So that's something that's kind of interesting, kind of unique to the tropics, and it explains why we tend to get the squalls at night. So let's switch gears a little bit and talk about some of the challenges that are specific to moving south along the US East Coast in the fall. Remember that we want to think of the atmosphere in 3 zones. And the first zone, when we're leaving from, let's say, the Chesapeake Bay, is those low pressure systems and cold fronts that are going to come through every couple of days. We are typically going to see some strong southwesterlies ahead of those, maybe some really nasty squally weather along the front, and then behind the front, maybe a brisk northwest wind. But as the wind veers from the northwest to the northeast and east and southeast, it typically gets fairly light. And then once again, the wind is going to build as it veers from the southeast to the southwest to the west, ahead of the next approaching low pressure system and cold front. Sometimes the spacing between those significant areas of low pressure and cold fronts can be really, really short. Sometimes we only get 24 or 48 hours between low pressure systems and cold fronts in late October, early November. So oftentimes we will be leaving the Chesapeake Bay on the heels of a cold front when the wind is still northwest at 30, in anticipation that by the time we get to the Gulf Stream 14 or 18 hours later, the wind will have started to veer around a little more to the northwest or north and settle down to something more reasonable, and the seas will have started to settle down and the wind will be from a reasonable direction. By the time we're getting through the Gulf Stream, maybe 18 to 24 hours after departure, we're probably in an area of relatively light wind. We may have to do some motoring across the stream. And then once we're out of the stream, we typically pick up a building south and southwesterly flow again ahead of the next area of low pressure. Now, sometimes there's not even that much space between areas of low pressure, or the high between the lows is too far north and we don't get as much moderation as we would like. So let's say that a cold front passes, but instead of the area of high pressure moving over us between fronts where the wind would get really light as we go through the Gulf Stream, let's say the high is moving through Quebec or New England between the cold fronts. In that case, the wind might veer from northwest at 30 to northeast at 20, east at 20, southeast at 20, and back to southwest at 30. And in that case, we really wouldn't have a window because when we're trying to go through the Gulf Stream, we're going to have wind veering on the nose 20 knots and blowing out of the northeast against the Gulf Stream. So we really need to see enough time between cold fronts and enough time between low pressure systems, along with the high pressure system being in the right place between fronts, so that we get the moderation when we're moving across the Gulf Stream and not a headwind or a significant wind blowing against the stream. That can be a challenge in early November. Some years it's just fine. I would say more years than not. We have weather that's quite suitable within a day or two of our intended departure. But there are some years where we don't. And I remember, I think it was the year 2010. I'm still having PTSD about it. We thought there was a window that was going to be okay to leave, and it was a deteriorating forecast. So, 3-4 days ahead of time, it looked really good. A couple of days ahead of time, it still looked okay. The morning everyone was departing, we were doing the Caribbean 1500. That was one of the first years of Salty Dog Rally. It's 2010 or 2012. I forget exactly which year it was. May have been 2012. But the morning that all the Salty Dogs were leaving, I got up and I looked at the forecast. I'm like, I wouldn't really go today. It looked like the window was closing. It looked like there wouldn't be an opportunity, especially for the slower boats, to get across the Gulf Stream. And, we learn things over time. And what I learned from that is that I should have spoken up, and people would have been really, really disappointed when I emailed out at 6 or 7 o'clock in the morning, when everyone was starting their engines and getting ready to go out the bay. They would have been really disappointed for me to say, it's, we thought it was going to be good and it's just not good. I wouldn't go. But I should have said that, because it was really, really bad. So, in the future, if we get a situation like that, you may get an email at 6 o'clock in the morning on the day of departure saying, sorry, stuff changed, I wouldn't go. And, I'll try to get more specific than that. Mike and Tina, do you typically leave in the morning or the evening? You typically want to leave at whatever the appropriate time is to time you're crossing the Gulf Stream when it's the best weather. And that can be a morning, afternoon, evening, or overnight departure. It varies. Obviously, we would like a morning departure. So all else being equal, if there's no significant reason not to leave in the morning, we'll suggest a morning departure. But if there is a significant reason that you would want to leave at a different time, we'll suggest leaving at a different time. Could there be different go windows for boats to the Bahamas versus Antigua? Yes, indeed. There will be. And there are different go windows based on different speeds of boats too. We'll talk a little bit about more about that when we talk about New England here in a second. And was that the year the NARC Rally lost several boats? It may have been. I think there have been a few of those years. But the year that really sticks in my mind where the NARC Rally lost a couple of boats was when there was a tropical system, and the folks we worked with, and we did work with a lot of Salty Dog Rally participants who left with a tropical storm, or at least the potential for a tropical storm to be brewing. And the routing that we suggested was, it wasn't going to Bermuda. It was staying on the west side of the storm. And the vessels who made that trip that year and left roughly on the intended departure day, and were out there with a tropical system it was a strong tropical storm, it was almost a hurricane. They had a great trip down to the Caribbean. They were sailing on a broad reach the whole way. So what that was area of low pressure, counterclockwise winds. And we were able to keep the vessels moving south through the Gulf Stream, south toward the Bahamas. And then at the appropriate time, they made a turn to the southeast and east, and then south down into the Caribbean. And for about 80% of the trip, they were sailing in broad reach conditions that were quite reasonable, in the 20 to 30 knots range with reasonable seas, because they were on the west side of the low. And the problem that the NARC rally folks got in was they were on the other side of the low. They were on the northeast side of the low, where there was a much tighter pressure gradient and where they didn't have any options. The only option to deviate course would have been more downwind, which would have been more directly into the path of the low. So they were left without any good options. When you're transiting the west side of a tropical low that's moving kind of to the northeast, you've got a lot of options. You can move a little closer to the low if you want a little more wind. You can move a little further away if you want a little less wind, but you're all in broad reaching to downwind running conditions. So you're all fine. And the gradient field tends to be more uniform and more broad on that side of the low, because that's the side of the low that's opposite from where the high pressure is. So if we're wrong a little bit, then, you know, on the course, then the wind speed won't change dramatically. But if you're wrong a little bit on the other side of the low, the wind conditions can change dramatically. Yeah. And I'll get to some of the other questions in a minute. So let's talk about leaving from New England. So if we're leaving from New England, we've got a couple of options. We can go to Bermuda, we can go to the Caribbean, or we can go down to the mid-Atlantic states. The challenge here is that instead of the Gulf Stream being 14 or 18 hours away for the entrance and not more than about 24 hours away for the exit for most boats, as you would have leaving out of Chesapeake Bay, we've got about 300 miles to cover before we're out of the Gulf Stream if we're leaving from Newport. And, you know, most typical cruising boats that go 150 miles a day are going to need 48 hours of reasonable weather from the time they depart till the time they exit the Gulf Stream. And typically in late October, early November, we do not have that long between cold fronts. So if you are leaving from New England in late October, early November, then you'd better have one of the following things be true. Either you can make 200 miles a day, in which case you only need 36 hours to get across the Gulf Stream. Or if you're moving a little slower and you need 48 hours to get through the Gulf Stream, you need to have unusually good and unusually long intervals between low pressure systems and cold fronts. So where most of the time we could leave out of Norfolk with reasonable conditions in late October, early November, maybe only waiting a day or two or three for weather, leaving out of New England in late October, early November, we've got a much lower probability of having a sufficiently long window to make it across the Gulf Stream in reasonable conditions. Indeed, there have been winters where there were no breaks in November, and we've had, so what do you do if there are just no breaks in early November? Well, you've got a couple of choices. One is you can go out there in gale force winds and just deal with it. The second is you can hop along the coast down through the mid-Atlantic states and leave as soon as you get to the Chesapeake or to Beaufort. But doing that is against the prevailing winds, which are typically southwest. And so you may have to go through Long Island Sound, then down to Jersey Shore, and then down to the Chesapeake, making 12 or 18-hour hops during the 12 or 18 hours between low pressure systems and cold fronts where you don't have a strong southwesterly wind. But that obviously can take some time, and you may have crew considerations. You may lose your crew. Thanksgiving is approaching. And the other thing that we've had, if you don't want to get out there in gale force winds and you don't want to be hopping down the coast in short hops, we've also had clients just cancel their winter plans and say, it's just not doable this November. We're not going to leave. We're going to stay in New England for the winter, which is unfortunate, but for some folks, that's the right decision. So, what else could we comment about? I guess we'll go back to this chart and we'll look at leaving the Chesapeake Bay we've got three options: go to Bermuda, go to the Caribbean, or go to the Bahamas. And the decisions and the go, no-go considerations are different. If you are going to Bermuda, then you are typically going to stay in that northern zone where the cold fronts are coming through with fair regularity, probably the whole time to Bermuda. You may get into the middle zone where you're under the subtropical ridge for a little bit of it, but then another cold front is going to come through. So you're mostly in the area where you're going to get a couple of cold fronts on the way to Bermuda. If it's a 4 or 5 day trip, you'll be looking at 2 or 3 cold fronts. So we want those to be relatively weak fronts, or you'll want to be prepared for some relatively heavy weather. If you're going to the Caribbean, the idea is to leave at the appropriate time behind a cold front so that you get across the Gulf Stream with the least chaos and havoc and bad weather in the stream. And then once you're south and east of the stream, you want to try to make enough easting so that once you get into the trade winds south of the ridge, you are at enough of an east longitude that you can move south in the trade winds. So if the trade winds are going to be east-southeast like is depicted here, then you may have to go all the way to 65 or 64 or 63 or even 62 west before you enter the trade winds, or you're not going to make your destination. So we want to use once we're out of the Gulf Stream, we want to use any southwesterlies that we have left to try to go more in an easterly direction, maybe not straight east, but maybe generally toward Bermuda. And then when the southwesterlies kind of go away, we want to aim for a point at which we want to intersect the trade winds. But there can be a lot of motoring in that middle zone along that high pressure ridge. So if you don't have a lot of motoring capability, then we may have to work a little more closely trying to maximize your sailing and minimize your motoring. If you got plenty of motoring capability, then you can just motor through the light winds to the area where you want to pick up the trades and then go south. Let's say that there's a nasty trough. So let's say that a cold front presses all the way down to 25 degrees north latitude. Let's say that a cold front moves down to 25 north, 65 west and stalls. And high pressure fills in on the north side of it, and the frontal boundary persists, and it's really nasty and squally and really windy. We can get a compression zone on the north side of that frontal boundary caused by the high to the north of it. Remember, the lingering frontal trough is going to be an area of relatively lower pressure. So there can be a compression zone caused by the high pressure system versus that lower pressure along the frontal trough. And we can see wind, around 25 north, 65 west. We can see wind that is east-northeast or east or even east-southeast at gale force. Maybe, 25, 30, 35 knots, gusting 40 or 50 in squalls and thunderstorms. So if that's going to be the case, we're going to want to time your transits through that trough for a time when there's relatively less of a compression zone and when the trough is relatively weaker. And we are also going to want to ensure that, even if conditions aren't that bad, that you have enough easting in before you turn south that you can handle any winds that are maybe in the 20 to 30 knot range with 8 or 10 foot or 12 foot seas on a beam reach or a broad reach. And in order to be on a beam reach or a slightly broad reach, you're going to have to make a lot of easting before you get into the trade winds. So, that doesn't always happen, but it happens occasionally. So that's, I can't give you a specific point at which you're going to enter the trade winds because it varies. Sometimes it's really important to make a lot of easting when you're in that high pressure ridge. And sometimes you can choose a little bit more of a rum line, and it's not particularly important to make a lot of easting when you're under the ridge. So what happens if we're going down to the Bahamas? Well, the first challenge is getting around Cape Hatteras and through the Gulf Stream. And you will probably have a somewhat different entry and exit point, but one option will be to do the Gulf Stream just off of Hatteras. And then you'll move southeast across the stream because the stream is flowing northeast and you don't want to fight it by going south. So you'll be going kind of southeast across the stream. And then once you're out of the stream, you may be around 34 north, 74 west out in here, and then move kind of south-southwest back to the Bahamas. The cold fronts are not quite as strong typically and not quite as frequent along this route, but still it's 5 days, and the cold fronts do often get down into the Bahamas in early November. So we've got a plan on probably seeing one passage of a cold front on the way to the Bahamas. And that's going to be characterized by what? Wind veering from the northeast to the east, to the southeast, to the south, to the southwest. Well, at some point, that's going to be a headwind. So we want to ensure that you are either in a location where you can deal with a south wind at a reasonable sailing angle, or we want to ensure that the wind is light enough that you can kind of motor sail into it without it being too much of a problem. If the windows are really short, then what we may see is an opportunity to leave from Hampton, going around Hatteras and into Beaufort, or around Hatteras and into Southport, and then wait for the next window to cross the Gulf Stream and go to the Bahamas. And by leaving from Beaufort or Southport or Charleston, we've shortened the trip by about a day if we're leaving from Beaufort versus Hampton, or by about 2 days if we're leaving from, let's say, Charleston versus Hampton. So we need a shorter weather window in order to get down to the Bahamas. So that would be, one thing to consider when we get into late October, early November, is if we don't have a window to go all the way to the Bahamas, maybe we make a shorter hop and then look for the next opportunity to go to the Bahamas from somewhere south of Hatteras. Let's see. So I just want to cover maybe one more thing, and then we'll wrap it up and get into any questions. So what if you're leaving from, let's say, the Bahamas or Florida and going down to the Caribbean? So we get a lot of questions from folks saying, I want to leave from Florida, or I want to leave from the Bahamas. Where should I leave from in the Bahamas to go down to the Caribbean? And the answer is you can really leave from anywhere you want to go down to the Caribbean, typically in winter or spring. Now, there are some weather patterns that are really inclement, where we just get really persistent, strong easterly winds. And it tends to happen more in La Nina winters, which we've had a couple of recently. And it looks like we might have a third one this year. But we'll see. But those tend to be characterized by more high pressure in the Northwest Atlantic and over Greenland and Newfoundland and Labrador, and stronger trade winds, stronger easterlies, both in the Caribbean and in the Bahamas. And not so good opportunities to go east from the Bahamas to the Caribbean. But that doesn't last all winter. It'll be maybe a month or 6 weeks, and then we'll get some breaks. So as long as we're not in one of those periods, we can go pretty much anytime from Florida or the Bahamas to the Caribbean, and you can leave from pretty much anywhere you want. But the difference is going to be your routing. And if you're leaving from Florida, typically you can go pretty much straight east, and then, maybe catch a cold front in here, do a little bit of sailing, and then you've made enough easting and you can turn south toward the Caribbean. The further south you leave from in the Bahamas, it's fine. You can leave from anywhere in the Bahamas, even the Turks and Caicos. But typically the first 24, 36 hours or so leading out of the Turks and Caicos, you're going to be headed northeast toward Bermuda. And you're going to be looking at your GPS, and you're going to be getting really frustrated and disheartened because the GPS says you're not getting any closer to the Caribbean. Indeed, you may even be getting further away. Just turn the GPS off or ignore it. Just don't don't use a waypoint to the Caribbean. The strategy here is that you're trying to get out of the easterly trade winds so that you can go east. If you just try to go straight to the Caribbean, it's just not going to work. You're going to be motoring straight into the wind, and it's typically a pretty strong and pretty steady wind. So just come to terms with the fact that you're going to have to be going toward Bermuda for a day or two, and that's going to get you into light wind, at which time you can motor east and then turn southeast and south. And that's the easiest way to get to the Caribbean in the winter if you're in the Southeast Bahamas or the Turks and Caicos, even though it is, a 4 or 5 day trip. And leaving from the US East Coast, you may think that, things aren't looking great to leave out of Hampton, so down to the Caribbean. So I'm just going to work my way down the coast and, maybe stop in Beaufort, but then continue to Southport, Charleston, Brunswick, Jacksonville. And you're going to be thinking that you're getting closer to the Caribbean when in fact, you're putting yourself in a more and more difficult position potentially as you get further west, because look at how much easting you have to make in order to get out to, let's say, 65 degrees west longitude by the time you get into the trade winds. If you're leaving from Beaufort, you're at 7640 west. And if you're leaving from Brunswick or Jacksonville, you're at 81 or 8120 west. So you've got another 300 miles to go east if you are leaving from somewhere as far west as Georgia or North Florida. So if you're heading to the Caribbean, typically I wouldn't really go any further west than Beaufort along the southeast US coast. Maybe you do a hop if you don't like the weather when we get into the 1st of November. Maybe you follow the Bahamas bound folks around Hatteras and into Beaufort, because typically the weather windows are better leaving from Beaufort. And one of the reasons, two main reasons for that. One is that the Gulf Stream is much closer to Beaufort. So if you get a really short weather window, it would typically be 14 or 18 hours to the Gulf Stream entrance from Hampton, and maybe 24 hours, give or take, to the Gulf Stream exit from Hampton. But the Gulf Stream is only about 40 miles off of Beaufort. So you can be in the Gulf Stream in 6 or 8 hours out of Beaufort and out of the stream in 12 or 14 hours after leaving Beaufort. Not only that, but the further south you are, the cold fronts tend to be weaker and a little more space between them. So you have typically a longer, milder weather window, and you don't need as long a weather window if you're leaving from Beaufort. Now, if you're stuck in Beaufort for a month, you might start, gnawing your arm off because you're so bored. Not to put Beaufort down, it's great, but I'd much rather be in Hampton as a place to stage. But if we get to early November and you want to depart Hampton, but if you don't like the weather to the Caribbean, then consider just going around Hatteras, stopping in Beaufort, and then taking the next opportunity to leave from Beaufort. There are more reasonable opportunities to leave from Beaufort than there are to leave from Hampton. So that's what I've got this evening. What other questions do we have? How do we account for different boat speeds leaving from Hampton? So we will refer to faster and slower boats in the forecast. Oh, so what forecast forecast products will you expect from us? So we'll do a couple of webcasts before departure. So definitely participate in those. When you sign up for the rally, a couple of days before the rally, you'll start getting our regional daily email forecasts, which will give you some idea about weather conditions along the coast as well as in the Bahamas and the Caribbean. But those forecasts, those regional email forecasts, don't really focus on offshore conditions. You'll get some idea by reading where the high and low pressure systems are in the cold fronts. But those regional daily email forecasts are intended for use in the Caribbean and in the Bahamas and along the US East Coast, but not for long offshore trips. The Salty Dog email forecasts you will get starting a couple of days before departure. We'll start those about the same time we start the webcasts. Those are going to deal specifically with the Salty Dog Rally. Those will cover offshore conditions, but we will group vessels. And so you won't get a forecast just for you. You'll get a forecast for the boats that are kind of in your general area. And so on departure out of Hampton, we're going to talk about faster vessels versus slower vessels. And typically the faster vessels are going to be moving at 7 knots plus average, so 170 miles a day or more on average. And the slower vessels are going to be moving at 6.5 knots, so 140, 150 miles a day on average. So just figure out which of those two groups you fall into, and that'll be, faster boats versus slower boats. During the rally, those daily regional email forecasts will continue. Sometimes it won't be regular at 24-hour intervals, and the forecasts, especially as the fleet disperses, the forecasts may tend to focus more on certain groups than other groups. And we may send the forecast out in a couple of parts because it would be too long if we sent it all out in one forecast. So we'll try to keep you updated with when to expect the next forecast for your group. But typically the timing between forecasts will be 24 to 48 hours. If you are in an area where we've got more concerns about the weather, then we're going to keep those updates more frequent. If you're in an area where we've got fewer concerns about the weather, and there's less changeable and less challenging conditions, then the updates may be a little less frequent. But again, we'll try to keep you updated on that. I understand from Bob that pretty much everyone has a satellite phone, which is good, because then you can receive those daily regional email forecasts and the daily Salty Dog email forecasts. If you happen to have just an InReach device, then you won't be getting any of that information once you leave the coast. But we can do forecasts one-on-one on the InReach. Just message us, and these details are included in your Salty Dog guide. So consult your Salty Dog guide with how to request the forecast. But if you tell us, where you are and your course speed and weather conditions, then we can shoot back a short forecast by the InReach for you. That's a little more time consuming for us, and it's not nearly the depth of information that you would get in the more detailed Salty Dog forecasts by email. So it's definitely better if you have a sat phone and you're doing email. And you can always call us if you've got a question. Sometimes the easiest way to reach out is by phone, and just send us a text message or give us a call on the phone. And one thing that will really help us, and it will help us to help you, is if you're really specific with your question. So some folks, especially when they send a text message, we'll get a message from an Iridium phone number, and it just gives like a location and course and speed. We don't know who that vessel is. So my first text back to you is going to be, who is this? And then once you tell me who you are, I'm going to look you up in the Salty Dog fleet or I'm going to look you up in our database to see what the characteristics of the vessel are. Are you a Salty Dog? This and this and this. So once I know who you are, then I can look you up and find out more about your boat and what your needs might be. And, but then my next communication is going to be, okay, and what questions can I answer? What is it that you need? So in the initial text to us, we need you to identify who you are, what your vessel name is, and tell us where you are, location, course, and speed, weather conditions, and then really specific about the questions that you need us to answer. Low on fuel, need to find wind. That is a specific question. We can give you a specific answer, and it'll be really useful. Need a forecast is not specific. Need a forecast, I don't know what your concerns are, what your issues are. I may or may not know where you're going. So try to be really specific with your questions, and you'll get a much better answer, and you'll get a much better answer much more quickly, because that's something that we can handle, much more quickly than if we have to do a lot of guessing. So a lot of times, the most frustrating thing in November and again in the spring, when we get inquiries from clients, is trying to figure out what it is they need. And, we try to guess, and usually we guess right, but sometimes we don't guess right. But the best way to request information is to be really specific with what you need, so we don't have to guess what you need.
Chris, there was a question about the amount of fuel, and how many days of motoring might we expect?
Yeah, so the amount of fuel you need is directly proportional to your patience. You can have more fuel and less patience, or you can have less fuel and more patience. But there is a trade-off, and it's a pretty direct relationship. So I know in our little boat, in our Morgan 34, we carry, even with jugs on deck, not more than about 50 gallons of fuel, and we have a pretty thirsty engine. So, 3/4 of a gallon to a gallon an hour, we can motor 5.5, 6 knots for maybe 50 hours. So that's what, 250, 300 miles, 300-mile motoring range. That's not very much by today's standards. But we've got a lot of patience. We'll sit and wait for wind as long as it's not putting us in a dangerous situation. We're typically not on a schedule. So, we're happy to ghost along at 2 or 3 or 4 knots for a couple of days, waiting on wind. There are some folks that would just absolutely drive them crazy, and they'd be going out of their minds because they're not moving at 6 knots. If that's your case, then you're going to have to carry more fuel. So how much fuel do you need? You may realistically need to motor 600 miles. It would be unusual to have to motor more than 600 miles on the trip south in the fall. On the trip north in the spring, I've seen times when it was over 1,000 miles of motoring. Our founders on Sapphire, the Knowles, Bill and Linda, I remember one year they left the Caribbean. They had a tendency to have multiple departures. They would leave, have an equipment problem, and return, leave a second time. Usually they got off the second time, but sometimes they had to return a second time and leave a third time. Well, this was a year that the weather looked really good when most of the boats were leaving. They had to return, I think, twice for equipment issues, and then they finally left. And when they left, there was no wind, and there was no prospect for wind. And so right from the start, we were suggesting that they conserve fuel, because we didn't know when or how we were going to find the wind for sailing. And they had to sail over 1,000 miles, and they ran out of fuel. And then had to sail the last bit when the wind finally filled in. So but 600 miles would probably be a good minimum, 600 miles motoring range on the trip down. Most boats should be able to do it with less than that. What's the maximum under most routes that you're away from land somewhere? So Tim, it's going to be well offshore. So you'll be 500 miles away from land. And you'll be, 500 miles from the US coast. You'll be 500 miles from Bermuda, 500 miles from the Bahamas, 500 miles from the Caribbean when you're out in the middle. If your insurance requires you to be within most of the policy limits that I've seen are either 200 or 250 miles, you can still do it. But you're going to be taking a course that's much more down toward the Bahamas, and then somewhat east, southeast, then east. And that last little bit of the trip can be really challenging when you're trying to go east from the Bahamas or the Turks and Caicos, because that tends to be in the trade winds. So if our timing is wrong, then you may have to stop in the Bahamas, refuel, recrew, and then look for another opportunity to go down to the Caribbean. So if you need to stay within 200 or 250 miles of land, it's probably more realistic to plan to go to the Bahamas and then head to the Caribbean from the Bahamas. We might get an opportunity to go all the way to the Caribbean, passing 200 miles east of the Bahamas, but it's not likely. That's fighting the normal wind pattern. In the normal wind pattern, as you see here, you're going to want to make more easting, then turn south. Your route, if you have to stay within 200 miles of the islands, is going to be more to the south, then the southeast, then the east-southeast. So you are going exactly contrary to the way the wind patterns go. Mike and Tina, some people leave and head to the Bahamas. Some don't like it and go to Beaufort. Do we provide weather to both groups? So we'll provide the weather for a limited period of time. So it's typically about 2 weeks, 2.5 weeks. If kind of the guide that we use is, if you are actively, ready to go, looking for the next window, then we'll keep supporting your travels. But if you decide you want to stop in Beaufort and you've got an equipment problem and it's going to delay you for a week or two, or you want to decide you want to stay there for Thanksgiving and then continue on after that, then the rally services would not cover you. We'll be glad to work with you individually after that, but it wouldn't be under the guise of the rally. But we coordinate with the rally administration on when is a reasonable time to terminate the services, terminate the support for the group. So we kind of do that on a case-by-case basis. But if you're headed to the Bahamas, you stop in Beaufort for weather, you take the next weather window out of Beaufort to go down to the Bahamas, you're certainly covered for that. When would you advise stopping in Bermuda after leaving Hampton for the Caribbean? So if we get a weather situation where you have to make a lot of easting before you get to maybe 30 degrees north latitude, so if the subtropical ridge is really far north and the boundary of the trade winds is really far north, let's say that by the time you get south of 30 north, you're going to be in the trade winds, then you would want to be passing pretty close to Bermuda anyway. And a lot of folks, especially who don't carry a lot of fuel, might want to put into Bermuda to refuel. So one situation where it would make sense to go to Bermuda on the way to the Caribbean is if there's if the routing is taking you close to Bermuda anyway, and there's some reason that you need or want to stop. I would note that in wintertime, the weather in Bermuda can be pretty foul, and it can be difficult to get out of Bermuda. What often happens in Bermuda when we're looking for a departure in November is a really strong cold front, low pressure system comes through. It blows 30, 40 knots, 50 in squalls, really nasty, huge seas. And then high pressure comes in right behind that and kills the wind, and you've got a leftover sea and no wind. And then ahead of the areas of low pressure and cold fronts, you've got a south wind. So you obviously wouldn't want to leave with a south wind. So you're going to be leaving behind a front. But oftentimes that is with a lot of wind, pretty big seas, and then a rapidly moderating wind, leaving you with 10-foot seas from behind you and no wind 24 hours out of Bermuda. So you leave with northwest at 30. A day later, the wind is completely gone, but there's still a 10-foot sea from behind you and you're rolling around and it's really awful. So if you stop in Bermuda, it may not be a quick departure if you want mild weather. Many boats today who are making these trips are 50 and 60-foot boats that are professionally crewed, and they're really on a schedule. And so they're going to leave with northwest at 30, a day later, 10-foot seas with no wind, and they're just going to suffer through it. And, but on my little 34-foot boat, I would wait for better weather, but it could be a while if you're trying to leave Bermuda in November. What air temps can you expect before crossing the Gulf Stream? Clothing prep. So yes, it is going to be cold. Typically it is going to be freezing at night, 30 degrees, between 30 and 40 degrees at night in Hampton in early November. And if you're leaving from New England, it may be more like 20 to 30 degrees. So you're going to be leaving in freezing or near freezing conditions. The Gulf Stream is really key, though. Once you're in the Gulf Stream, it warms up, and within 24 hours out of Beaufort, you'll be shedding all of your heavy gear and going for t-shirts and as light a PFD as you can find, because it's really hot and humid. So you don't have to put up with that very long, but yes, it is cold for that first day out of Hampton or the first 2 days or so out of New England. Does it make sense to go from Hampton to Beaufort to Bermuda? The decision to go from Beaufort to Bermuda versus Hampton to Bermuda is similar. It often is about the same, whether you leave from Hampton or Beaufort if you're heading to Bermuda. The specific forecast can be a little different. The initial strategy can be a little different, but often you're gravitating toward the same point. You're leaving out of Beaufort, moving east or east-northeast to the waters off of Hatteras. And typically those two courses are going to converge somewhere southeast of the Gulf Stream. And then you'll be on the same route as you would be if you were leaving from the Chesapeake Bay. So it's not necessarily better or worse to be leaving from Beaufort versus leaving from Hampton if you're going to Bermuda. And okay, Tim, you're asking for 600-mile offshore coverage. That would be good. And do we use observation from boats in the forecast? Yes, absolutely. Those are really helpful. So be sure to send along your observations, particularly if it's something unexpected. If you're getting anything that you weren't expecting from the forecast that you're using, then we really like to know about it. And we'll let other folks in the area know what you're experiencing too. And any other questions? How many days passage from Hampton to Marsh Harbor? Typically 5. Depends a little bit on the speed of the boat. It would be unusual to see it much less than 5. And if you're a slower boat, it might be 6 instead of 5. But it's typically about a 5-day trip from Hampton, about a 4-day trip from Beaufort, and about a 3-day trip from Charleston. You can cut half a day off if you're really fast. You can add up to a day if you're really slow. Pretty safe to say your crew that's departing for the Bahamas should be 1 to 5 days from November 1st, Bahamas bound. Not sure I understand the question. But, if you're looking to leave around about the 1st of November, then yeah, have crew plan to be there around about the 1st of November. You'll probably get a departure opportunity either on the intended day or within 2 days of intended departure. Most likely, we can find an opportunity within 2 days of intended departure. And hopefully that's an opportunity to go all the way to the Bahamas, but it might only be an opportunity to go to Beaufort. And then we're looking for the next opportunity to go to the Bahamas. So best case scenario is you get crew there on November 1st. There's an opportunity to leave on the 1st or the 2nd, and you're in Marsh Harbor 5 days later, which would be what, the 7th, maybe. Worst case scenario is you get crew there on the 1st. There's no good weather window to leave till the 3rd or the 4th. That's only to go to Beaufort. And you're waiting a couple of days in Beaufort. You leave Beaufort around maybe the 7th or the 8th, and you're in Marsh Harbor, more like the 12th. So it could be that you've got crew around for 2 weeks if the weather doesn't cooperate. If the weather does cooperate, then, you might only need crew for 5 or 6 days.
Okay, anybody else have any other questions before we wrap it up? Chris, this has been really very, very helpful, I think.
Great.
And as Chris mentioned, there'll be some additional briefings as we get a lot closer to departure time. And if you have any other questions, you can either send them to me. You can obviously send some emails to Chris, and then we have others in the rally coordination team that can answer any other questions that are starting to come up at this point. So once again, thanks very much. And reminder, we have another briefing on our next webinar is on Tuesday, and that's going to be a discussion on rigs and pre-departure rig inspection and such. So I think if you haven't done that yet, it's worth having a listen. So we'll see you then. You may not see me because I'm trying to move my boat from New York to Annapolis. Hopefully Chris will help me find a window and we'll get there. So with that, I'm going to stop the recording.
Sheldon, I see you typing a question. Just email me that question and we can communicate by email.
Yep. Okay.
Chris, it wasn't a question, just informing you.
Okay, great.
All right. Thanks, everyone.
All right. Good night.